Hello, I am Sayantika Adhikari and I am serving as an audio navigator for the subject Material Science. The subject is divided into 8 sections. Section 1, Processing of Materials. Section 2, Characterization Techniques. Section 3, Structure and Imperfections. Section 4, Thermodynamics and Kinetics. Section 5, Properties of Materials. Section 6, Material Types. Section 7, Environmental Degradation. Section 8, Elements of Quantum Mechanics and Mathematics. In this audio, I will give you an overview of Section 1 and Section 2 and tell you how to prepare yourself with these two sections for GATE. Starting with Section 1, which is Processing of Materials, the subtopics are powder synthesis, sintering, chemical methods, crystal growth techniques, zone refining, preparation of nanoparticles and thin films. The first subtopic is powder synthesis. Now, a powder can be defined as a finely divided particulate solid. The engineering powder include metals and ceramics. The geometric features of engineering powders are particle size distribution, particle shape, and internal structure, surface area. Metallic powder are classified as elemental, consisting of pure metal, for example, iron, aluminium, and copper, and pre-alloyed, where each particle is an alloy like stainless steels. Certain copper alloys high-speed steel. The characterization of powder is important. The sizes and shapes are important in blending and compaction. The parameters related to powder size is also important. The particle size is measured are powder sieving, sedimentation technique, laser technique. Terms like packing factor, porosity are important. Go through the relations expressed in these terms. The powder synthesis occurs by blending and mixing, powder compaction, sintering, and finishing operations. Blending and mixing is done by rotating drums, blade, and screw mixers. First, the pressing, where the powders are compressed into desired shape to produce green compact. Next comes sintering, where green compacts are heated to bond particles into a hard, rigid mass. Get a detailed study starting from powder fabrication, size and shape characterization, microstructure, chemical homogeneity, and particle size, followed by processing, which include compaction, sintering, forging, or heat pressing. Then last comes the properties, which include density, porosity, ductility, strength, conductivity, etc. Now, the metallic powders are commercially produced by 3 methods: atomization, which is by gas, water, and centrifugal; chemical; and the third, electrolyte. Get a surplus study on each method. There may be multiple choice question from here, and it will be based on the theory of the methods and the process, like oxide reduction process for metal powder fabrication, carboxyl process, electrolysis process, and mechanical milling. The next subtopic is sintering. As mentioned earlier, it is a heat treatment to bond the metallic materials to increase strength and hardness. They generally include this in match the following. You should have a detailed study on every topic. They ask questions often to confuse the students. The sintering process has 3 stages. The pressed powder compacts are heated in a controlled atmosphere to right below the melting point. The 3 stages of sintering are burn off, which is purging, the second is high temperature, and the third is cooling period. The burn-off purging combusts any air and removes lubricants or binders that would interfere with good bonding. The high temperature is where the desired solid state diffusion and bonding occurs. The third, which is cooling period, lowers the temperature of the products in a controlled temperature. Terms like sintering cycle and furnace, sintering time, temperature, and their properties, you should be familiar with this. There is an expression for volume shrinkage, which is equal to volumes of sintered by volume of the green compact. A term called linear shrinkage is equal to the density of the green compact to the density of the sintered to the power 1 by 3. In 2016, there was a multiple choice question to match the process and product, carrying 2 marks. The next subtopic is crystal growth technique, which involves a phase change from solid or liquid or gas phase to a crystalline solid phase. Electron grade silicon EGS, a polycrystalline material for the preparation of single crystal silicon. The metallurgy grade silicon is not suitable. Characterization technique, which is also known as CZ technique, is the crystal growth. CZ technique involves solidification of atom in liquid state at the interface. In the crystal growth process, polycrystalline silicon EGS is placed in the crucible and the furnace is heated above the melt temperature of silicon. A seed crystal is suspended over the crucible in a seed holder. The seed is inserted into the melts, part of it melts, but the tip of the remaining seed crystal still touches the liquid surface. It is then slowly withdrawn. Progressive freezing at the solid liquid interface yields a large single crystal. The wafers are obtained by cutting single crystal into thin slices. Typically, wafers have dimensions. Surface grinding and polishing operations follow. Then it is followed by chemical etching. The next subtopic is zone refining, which is a method of purifying a crystalline solid, typically a semiconductor or metal, by causing a narrow molten zone to travel slowly along an otherwise slide rod or bar to one end, at which impurities become concentrated. In 2010, there was a multiple choice question to match the appropriate preparation technique with the materials produced, which included Characterization technique, hot pressing, sol gel, melt spinning. It carried 2 marks. In 2008, there was a multiple choice question on particle size carrying 1 mark. Likewise, you can expect 2 marks from this chapter. Now, the next subtopic is preparation of nanoparticles and thin films. The various techniques for preparation of nanomaterials are sol gel synthesis, colloidal precipitation, co-precipitation, combustion technique, hydrothermal technique, high energy ball milling, and sonochemistry. Here the sol gel synthesis is a wet chemical technique. It is a chemical solution deposition. For gel-like properties, particle density should be increased by removing significant amount of solvent. Next comes colloidal precipitation. Here synthesis of nanoparticles of gold and silver is done. Franz Turkevich method is important here. The next is co-precipitation. It is simple and low-cost process applicable to preparation of magnetic nanoparticles. For example, iron oxide nanoparticles are synthesized by co-precipitation reaction of ferric chloride and 1, 2, 4, 5 benzene tetracarboxylic acid. There is an experiment procedure for this process. The next is combustion technique used for preparation of nanoparticles sized lithium bismuth dioxide. This is an experimental procedure for this where we require lithium nitrate, bismuth nitrate, urea glycerol. Go through the procedure. The next process is hydrothermal technique conducted in steel pressure vessels called autoclaves with or without Teflon liners. It occurs under controlled temperature and pressure with the reaction in aqueous solution. It is widely used for production of small particles in ceramic industry. It is used to prepare nanoparticles of titanium dioxide. The experimental process includes hydrothermal treatment of peptized precipitate of a titanium precursor with water. Precipitates are prepared by adding 0.5 molar isopropanol solution of titanium butoxide into diionized water, then peptized at 70 degrees centigrade for 1 hour in the presence of tetraalkyl ammonium hydroxide. The powder obtained is washed with deionized water and absolute alcohol and dried at 60 degrees centigrade. Similarly, every technique has a procedure. You have to make note of each experimental procedure. They may ask questions based on the procedure like which peptizer is used for synthesis of titanium dioxide. As it is included in your syllabus, you must study this properly. Moreover, they won't give more than 2 marks from here. You can remember the names of each method I have mentioned under each subtopic. They have generally asked direct questions like the method and its relevant product or its application. The next for preparation of nanoparticles is high energy ball milling. It is utilized in industries to perform size reduction. It is induced for structural changes and chemical reaction by mechanical energy rather than thermal energy. Reaction are possible at room temperature and so non-equilibrium in nature. The milling process embraces a complex mixture of fracturing, grinding, high-speed plastic deformation, cold welding, thermal shock, intimate mixing, etc. It produces a large range of nanoscaled materials like nanocrystalline materials, nanoparticles, nanocomposites, nanotribes, nanowires, and nanorods. You require a scrupulous study on all these techniques. Prepare a note. These topics are very easy. There are no numericals from here. Now, I have been mentioning each and every technique elaborately, giving you an overview so that it will be easy for you to understand each topic, at least know its name and the basic of these techniques. Then comes preparation of thin films. A thin film is a layer of material ranging from fractions of a nanometer to several micrometer in thickness. The film technology is a self-organizing structural evolution. The thin films are prepared to maintain uniformity, to reduce the amount of light-absorbing material, to decrease the weight and bulkiness of the materials. The deposition technique it is done to controllably transfer atoms from a source to a substrate. It includes evaporative methods, glow discharge technology, gas phase chemical process, liquid phase chemical formation. The ultrasonic nozzle technology is also an important topic here. The chemical vapor deposition is where gaseous compounds react to form a dense layer on a heated substrate. The most widely deposited wear-resistant coatings are titanium TiC, titanium nitrate, chromium carbide, and alumina. Deposition temperature are generally in the range of 800 to 1000 degrees centigrade. Then comes the physical vapor deposition, the low pressure coating process in which the coating flux is produced by a physical process. These are evaporation and sputtering. This topic should be studied in detail. In 2007, there was a multiple choice question of 2 marks to match the experimental techniques with their applications. Zone refining was included there. You can complete this section within 2 days. You can prepare the notes on each technique I have mentioned in the subtopics. I've also mentioned the previous gate questions. I hope with this we complete this section 1, processing of materials. I hope you have got an idea that you must be familiar with the techniques, their applications, and their products. The next we start with section 2, which is characterization techniques. The subtopics are X-ray diffraction, spectroscopic techniques like UV, infrared, Raman spectroscopy, the optical and electron microscopy. The first comes X-ray diffraction. Here, the study of arrangement of polymer molecules into crystalline and amorphous region forms the basic objective of X-ray diffraction. It is primarily used to determine degree of crystalline in polymers. Depending on the angular regions of diffracted rays, X-ray diffraction can be categorized into two. Wide angle XRD is widely used and it covers a broad range of Bragg's angle 2 theta from 2 degree up to 60 degrees, while small angle experiments are carried out from a few seconds of arc up to a degree or so. Now, the Bragg's law of XRD, it is the easiest way to visualize the diffraction effects produced by the three-dimensional grating provided by the crystal. The Bragg's expression for reflection is very important. There are numericals every year on this. This equation can be used for determining the lattice parameters of cubic crystals. The powder method is also important, which is widely used for routine determination of a crystal structure. An expression where Bragg's angle and radius of the powder are related to the distance between any two corresponding on the spread out film. There is another structure determination expression for monoatomic cubic crystals. Practice the numericals. A 2-mark numerical is expected every year. Next subtopic is infrared spectroscopy, which is a powerful tool for identifying the types of chemical bonds in organic and inorganic molecule by producing an infrared absorption spectrum that is like molecular fingerprint. It can be utilized to identify the components of an unknown mixture. It is applied to the analysis of solids, liquid and gases. They generally ask multiple choice questions from here to match the techniques with their appropriate applications. The next topic is optical microscopy. The light microscope is often referred to as optical microscope. It is one of the most important techniques in the study of polymers as it is relatively simple and cheap. Terms like focal length, magnification, the image should be studied here in this principle. The condenser objective radiant field and aperture stop need to be adjusted for obtaining better image characteristics. The object which is situated outside the focal length of the object produces a real, magnified, inverted and intermediate image. The total magnification is calculated as the magnification of the objective M, which is denoted by M objective, and that of the eyepiece denoted by MI. The light microscopy allows the observations of objects which only after the phase relationship but not the amplitude of the light. It is suitable for three-dimensional representations of objects which differ only slightly in their mass thickness or possess only small difference in their surface profile. Another type of optical microscopy is polarization microscopy. It plays an important role in characterizing the structure of plastics. Spherolytic crystalline polymers as well as orientation and internal strains in plastics are assessed and determined by polarization microscope. Its application is in geometrical measurements to determine thickness of multilayer sheets, control of fiber, cross-section, measurement of size distribution of fillers, voids, specks, fish, agglomerates in plastics. It is used for the measurement on stressed polymer, measurement of multi-layer component polymer, measurement of semicrystalline polymer. The next is electron microscopy. There are various microscopy under this like scanning electron microscopy, transmission electron microscopy. The first is scanning electron microscopy, also SEM, is one of the most versatile instrument for analyzing the microstructural characteristics of solid objects. The greater depth of field of SEM helps in providing even minute details about the specimen. The specimen beam interaction is important. Different types of interactions of the electron beam are studied. SEM is used for examination of surface, examination of porous materials, determination of orientation, examination of behavior of material under stresses, examination of multi-component polymers. Next comes transmission electron microscopy, which is an important tool for microstructural characterization of materials. The images are based on the intensity of electron emerging the samples. The arrangement of atoms in the specimen and their degree of order, detection of atomic scale defects in areas can be examined a few nanometers in diameter. The elements and compound, that is, the composition of the sample and their relative ratios, can be minutely studied. It determines morphology of polymers, structure of multi-component plastics, distribution problem, topography of the sample. Another microscopy, that is atomic force microscopy, is also important. Each of these microscopies should be studied in detail with their principle and instrumentation. I have given you an overview of each of these characterization techniques, at least the ones which are asked every year. In 2016, a 1-mark multiple choice question on energy dispersive spectroscopy in a SEM based on the application was asked. There was a numerical on Bragg's law carrying 2 marks. Again in 2015, a multiple choice question of 2 marks was asked to match the techniques with their characteristics, which included XRD, SEM, STM and DSC. In 2014, a numerical answer type question of 2 marks on Bragg's angle was asked, and a multiple choice question of 1 mark on how the roughness of polysilicon wafer can be performed. In 2013, there was a numerical answer type question on Bragg's law and multiple choice question to match the microscopes with their principle. A total of 4 marks from this section. In 2014, a multiple choice question to match the characterization techniques with appropriate applications carrying 2 marks was asked. Again in 2011, there was multiple choice question to match the techniques and descriptions carrying 2 marks. So generally you can see that they may ask to match the characterization techniques. You have to be very thorough with each of these techniques. You go through the previous papers. Do not confuse yourself. Prepare the notes, revise them. You can predict, as I've already mentioned, of 4 marks from this section. It is very easy. The sums generally from the Bragg's law are also very direct. Solve as many numericals you can to improve your frequency, the time you take to solve these sums. 2 days should be given to complete this section along with the numericals. Hope you have liked my audio and it shall be helpful to you. Wish you good luck and thank you.